Another way to upgrade your bike is a little bit more complicated. It's pretty much porting. So, with porting, you gotta take your motor apart. There's no other way to do it. But this port job can do the most improvement for your bike, because it's pretty much the brain, the muscle of the bike is all in the motor. So upgrading the dynamics of the motor will do the most. Now, let's start with the cylinder. With the cylinder, how you port it, you want to make sure it's all unnecessary metal is removed. Now, I had a couple of unnecessary pieces of metal in here that I filed down and got rid of. What this does is it lightens up the piston so that it can go up and down a lot faster, producing higher RPM. With higher RPM and a lighter piston, it'll be easier for it to get to that high RPM, therefore improving acceleration. Now, what you can also do, other than removing weight from the piston, is polish the head of the piston. What this does is it makes it so that there's less surface area for tarnish to stick to and less surface area for heat to build on. Now, with less heat and with less stuff gumming up on here, this improves efficiency dramatically by removing heat. What that does is heat will not terminate any of the potential energy the motor has. So by keeping a motor running cool, it uses all of its power instead of losing its power to heat, therefore being more efficient. That's with the piston. Polishing and removing. Now, what I have here, depending on the type of motor you have, I have piston ramps. I've heard of people drilling windows into their piston. I am not sure on that. But I know these ramps help for sure. Now, if you look at my motor, it's got transfer ports that are exposed on here. Some motors have transfer ports with walls covering them, so they're like a tunnel. Now, if you have a tunnel type of transfer ports, you do not need to do this. But if you have opened, exposed transfer ports like this will help. So, when the piston is up all the way, it'll go down to press the gases in the transfer port, in the transfer case, up through here and up into the top of the cylinder. So it goes down. As it's going down, these ramps serve as a direction for the fuel and air to go into. So as it's going down, the air and the fuel will ramp up on the sides of here, and this ramp, as you can see, is angled to push it sideways. So as it goes down, the fuel and air go and ramp sideways. What this does is it puts more air and fuel into the transfer ports, which then go up into the combustion chamber and spark. Another thing you can do is do a crankshaft mod, like I have here. I read this online. It's called a turbo crankshaft mod. People do them on model boats, RC boats, and say it works. What this is as you can see, it's a regular shaft. It's not a full circle shaft, but the ends of it, where it spins, are sharpened so that it can spin faster without having as much drag. This is also good for a couple of reasons. This mod itself, not just for drag reasons, but my motor spits fuel and air at two different compartments. See here, this little cut right there is where the fuel comes from. Now I modified that so that it's pointed directly in the middle of the shaft, because it was only pointed to one side, which is really bad. So now it's getting even fuel and air on both transfer ports. But what this does is as it spins, it'll cut through the air and fuel and force it sideways. What this does is it forces it sideways into the combustion chamber, or into the transfer ports which lead to the combustion chamber. So this mod not only improves the speed of the crankshaft, but the amount of air and fuel that flow up into the combustion chamber, giving it bigger boom and bang, therefore making it spin even faster. So maybe that's how they call it, why they call it a turbo mod. Another mod is to do a gasket match. How you do this is you take your motor apart, and where your gasket was sitting, or if you buy a new gasket, line it up, maybe put some bolts on the holes, and you see where it's along the transfer ports, you cut it so that none of it is sticking out. I already did mine, matched it up, but it had a little bit of gasket that was sticking into the transfer ports, which, as you know, slows down the amount of fuel and air that's flying through there. So by cutting and removing that, you allow more air and fuel to be pushed into the combustion chamber and create a bigger explosion for the piston. One thing you could do also, this is the mount for my exhaust. Port it so that it matches the exhaust port. Now here, as you can tell, the size is different. One of them is rounded and one of them is rectangular. So couldn't ultimately match it so that it's identical, but I did my best to get it as good as I can possibly do it. Now what you do is you take little bits, and you take a Dremel, attach it to the Dremel, and just match it up to here. How you can find out what this size is? Well, use an index card and use your nails if you have nails. If you don't, that's okay. You could use something else that's sharp, and you press the hole in and use your nails kind of to scrape it. And what this does is, I did it really slowly, really fast, but if you take it, you use your pencil, line it out, you could see there is a shape. That shape right there is what you're looking for. See? You take your pencil, you outline it, and that's the shape of your exhaust port. Cut it out. After you cut it out, line it up on here, take a Sharpie, outline, trace what size that is, and then grind it up according to that size so you can match it up. That's what I did, and it worked really well. Matching your exhaust port will allow your exhaust gases to flow through a lot better, more efficiently, giving you better power and better thermal efficiency. So there's going to be less heat buildup, therefore making more power because there's less friction and power loss from the heat. Along with the exhaust port, we have the intake port. Here I have an intake manifold, or carb intake manifold attached onto here, so I can't really show you what I did. But for all ports, what you want to do is polish them. Sorry, not all ports, only exhaust port. Intake port I can polish because intake is not mixed with fuel yet. The fuel intake go into the transfer case separately. They don't go through here. But on most bikes, especially if they're reed implemented bikes, fuel and air will mix together. When fuel and air mixes together, you want it to be a rough surface. Why? Because a rough surface will provide the fuel and air to slide over the surface faster. If it's super shiny and slick like glass, it's going to form water droplets. Water droplets create drag. It's just it's almost like physics, where you just reduce the surface tension. So if you want faster flowing fuel and air, you want to make sure that the surface is rough. Use 80 grit sandpaper or around there. Not too rough, like you don't want to scar the metal. You just want to brush it so that it's not super slick. You want it to be rough for that surface tension not to be there. You want air and fuel to flow fast. What this will do is it'll provide better dynamics for high RPM situations, better speed, better acceleration, because more air and fuel can flow through the motor faster. What you can do is modify the transfer case. Here I have the transfer case, and I have, as you can see, done a little bit of work. Yes, it is my pride to show you. Here I have cut this metal, allowing the whatever substance in here to flow into this ramp a lot faster with a lot more volume. As you can see, I marked the direction of the flywheel, how it spins. Spins this way. So if you look at it, it'll spin this way. You want the air and fuel to fly up through here and directly into here. This ramp blocks it. Sorry. This lip right here blocks it from going from the transfer case directly into the ramp of the transfer ports. By allowing it to flow into there with less disturbance, you get a higher flow, more flow, and efficiency improvement. Another thing you can do to improve efficiency and compression is polish your cylinder rings. Here I have one cylinder ring. I used my Dremel and a little polishing tip on the Dremel. Used very fine uh, polishing compound. It's not designed. It's designed for last step application. But before you do this, you want to make sure you clean all the tarnish off. Use brake cleaner and rub it really well so that you're not polishing, garbage. You want it to be actually polishing the metal. What this does is it allows the piston to move up and down with less friction because it's polished, and with less friction, less heat is generated, therefore providing more efficiency and less power loss to heat. One thing you can do is every seal, every bearing you have in the motor, clean them up, and once they're clean, lube them up with motor oil. Less friction will obviously result to more power, and the seals, if once they're cleaned and they're lubed, they'll have less friction, and because they're lubed, they'll have no pressure loss inside the motor. No pressure loss means more efficiency, more power, and the motor's doing exactly what it's supposed to do, which is pushing all those gases and fuel mixtures all around without having it anywhere escape anywhere. So doing this will improve power and efficiency of the motor. Okay, porting. When you port your ports, you want your intake port and your exhaust port both to be a little bit rounded. So by doing this, when the piston goes up and down, see how it's round? There's no walls. It's literally round. Therefore, the piston can just slide over it. When it's rectangular, you create a up and down wall. The side walls do not create any friction, just this up and down wall that the piston travels up and down. They create walls so that the piston has possibility and hits it every time it goes down slightly. But by creating little burrs on the side, you don't just sand it down and just keep it like that. No, you have to make it so that there are little, see, as you can see here, the walls of this aren't sharp. You round the walls or the ends of this port so that the cylinder does not get caught up on them. So with porting, you want to make sure you don't go for volume and size. You just want to go for velocity and efficiency. Because if you think about it, you take a huge exhaust pipe, you blow through it, and you put your hand at the end of it. You will not feel too much power or air coming through it because of the velocity to diameter ratio. You don't have enough wind to blow through to actually fit that size. You need a little straw so that you can blow through and have velocity at the end of it. Same thing here. If you just create them bigger, yes, you might get more airflow, potential airflow, but there's not enough pump that's the cylinder is producing to really get that velocity. That pump that the cylinder is producing is all the power that you have to work with. That's your limit right there, is the cylinder pump, the cc of the motor. So by matching it with that and making it so that the air is directed, you get way more power. Now for the intake, what you can do is lower it. Lowering it will cause the cylinder, so when it's all the way up, it'll be opened up more right here at the bottom of the port, so that more air can flow through. This changes the timing, so be careful, do some research on it. Now for the exhaust, you can raise it. Now raising it, what this does is it changes the timing as well, lets the combustion air to flow through at a sooner rate. Ultimately, rounding out the ports will create this effect as well, because it'll raise and lower. But if you focus only on the side walls and round those out, the same that will not be an issue. Doing that would probably be my best guess if you don't know exactly what kind of mods you should do to your bike.